Welcome to Canrica's podcast, The Digital Shift.
Today, our mission is really to unravel the powerful, sometimes pretty overwhelming world of data analytics tools.
It's a big topic.
It really is. And, these are the sophisticated systems behind things like, say, Netflix's recommendation engine.
Oh, yeah.
Apparently responsible for something like 80% of what you end up streaming. That's data turning directly into engagement, into, well, value.
Absolutely. It shows the power when it's harnessed correctly.
But therein lies the challenge for businesses, right?
Sure.
Global spending on data analytics is heading towards, what, $230.6 billion by 2025?
That's the projection, yeah. A huge number.
Huge. Yet, so many companies seem to struggle, really grapple with finding the right tools for them.
Yeah, it's a common hurdle.
And making those smart choices, it seems critical. It's often the difference between truly thriving and, just getting by.
That's spot on. And fundamentally, these data analytics tools, they're really engines of insight.
Engines of insight. I like that.
Yeah, they're software platforms, applications designed to, gather, process, analyze, and then visualize raw data.
Okay.
They transform what often feels like this chaotic ocean of information, turn it into clear, actionable intelligence.
So taking the noise and finding the signal.
Precisely. Making sense of the massive amounts of data being generated, like every single second.
Okay, that's a great framing. Now, given how many tools are out there, it probably helps to break them down. Can we categorize them somehow?
Definitely. Thinking in categories really helps. It's not a one-size-fits-all situation at all. We
Well.
can generally group them into, let's say, 5 distinct categories.
Okay, 5. Let's hear them.
So first up, you've got business intelligence tools, or BI tools.
BI tools, okay.
These are your daily workhorses. Think dashboards, standard reporting, tools like Microsoft, Power BI, Tableau. You probably heard of those.
Yeah, definitely. Power BI and Tableau are big names.
They take complex data, make it visual, easy to grasp for quick decisions.
Makes sense. What's next?
Then you have programming-based tools. These offer incredible flexibility for really deep, complex analysis.
So more for the tech specialists.
Generally, yes. We're talking languages like Python, R, SQL. They let data scientists build custom models, run advanced statistics, query databases directly with, real precision.
Got it. More hands-on coding.
Exactly. Category 3 is self-service analytics platforms.
Self-service. So for more people.
Right. These are designed to bridge the gap, really empower everyday business users.
Ah,
Tools like ClickView, and actually Tableau fits here too, in a way.
interesting. Tableau in 2 categories.
Yeah, it spans both. But the self-service aspect means non-technical folks can explore data, create their own visuals without needing to write code.
That sounds incredibly useful. Democratizing data, almost.
That's a great way to put it, putting the power of data directly into the hands of those who need the insights.
Okay, category 4.
Fourth, we have specialized tools. These are laser-focused on specific jobs. Well, think Google Analytics for website performance. Everyone knows that one. Or Apache Spark, which is built for handling massive, real-time, big data processing.
So niche, but powerful in their niche.
Exactly. Very powerful within their specific domains.
And the last one, number 5.
And finally, number 5, data preparation tools. Critically important, often overlooked.
Data prep, cleaning things up.
Precisely. Before you can do any meaningful analysis, data is often messy, really messy.
I believe it.
So tools like Talend or K9Me, they're crucial here. They help organize, clean, and transform that raw, jumbled information into clean, structured data sets ready for analysis.
Like prepping ingredients before cooking, you said earlier.
Exactly that analogy. You need good ingredients for a good result.
That breakdown is super helpful. So with those categories established, let's dive into the specifics. Let's talk about some of the top tools really making waves right now. This is where it gets really interesting for people trying to choose.
Absolutely. Let's get into the heavy hitters. When you talk about impact, you have to start with Microsoft Power BI.
Okay, Power BI. We mentioned it under BI tools.
Right. It's Microsoft's flagship BI platform, consistently praised, very user-friendly interface, and its integration within the whole Microsoft ecosystem is, well, seamless.
That integration piece sounds key for many businesses.
It is a major selling point. And something cool is its AI-powered natural language query. You can literally type a question like, show me last quarter's sales by region, and boom, it generates a visual.
Wow, okay. That's getting intuitive.
Very. It's fantastic for financial reporting, tracking sales performance, operational KPIs, key performance indicators, you name it.
Sounds versatile. What about Tableau? You mentioned it twice.
Yes, Tableau. It's a giant in data visualization, really celebrated for creating these stunning, highly interactive charts and dashboards. It makes data look beautiful, which isn't trivial.
Visual appeal matters for communication.
Absolutely. Now, comparing it to Power BI, a key difference often missed. While both are great at visuals, Power BI's strength is that deep Microsoft integration. Smooth adoption if you're already a Microsoft shop. Tableau, on the other hand, often shines when you're pulling data from many diverse sources and need that really bespoke, almost artistic visualization. It might take a bit more setup, but the results can be incredible.
So Power BI for integration, Tableau for maybe more complex, diverse data storytelling?
That's a good way to think about it. Tableau is great for executive reports, complex data stories, especially with its strong geographic mapping features.
Interesting distinction. Now, you mentioned Microsoft's ecosystem.
Mm.
What about broader solutions? Maybe something all-in-one?
Good question. That leads us perfectly to Microsoft Fabric.
Fabric, newer on the scene, right?
Relatively, yes, and it's Microsoft's big play for an all-in-one analytics solution. It's really ambitious.
How so? What does all-in-one mean here?
It aims to unify everything: data movement, data engineering, data science, real-time analytics, BI, all under one roof.
That sounds massive.
It is. And what's really innovative are the integrated Copilot and generative AI features. They offer new ways to interact with data, transform it, create reports using AI assistance.
AI's everywhere now.
It really is. Fabric also uses that lake house architecture we touched on briefly.
Right, the warehouse plus data lake idea.
Exactly. It combines the structure and querying power of a traditional data warehouse with the flexibility of a data lake for raw, unstructured data, all in one unified system.
So who is Fabric best for?
It's really aimed at enterprises looking for data consolidation, unifying their big data analytics, integrating machine learning workflows more smoothly. It's also a natural migration path for folks using older Azure Synapse tech.
Okay, very comprehensive. Any other major platforms playing in that unified space?
Definitely. You have Databricks, another huge player, also built on a lakehouse architecture. It emphasizes an open, unified foundation for all your data, AI, and governance.
Open source roots there, right, with Spark.
That's right. Its computing engine is based on Apache Spark. Key features include really strong integrated machine learning tools like AutoML, which helps automate model building, and ML Flow for managing the whole ML lifecycle.
So heavy on the AI and machine learning side.
Very strong there. It's widely used for large-scale machine learning projects, real-time streaming analytics where speed is critical, and collaborative data science work, often across multiple clouds.
These platforms sound incredibly powerful, really pushing the boundaries. What about companies deeply invested in the cloud, maybe needing a specialized cloud data warehouse?
For pure cloud-native data warehousing, Snowflake is a major leader.
Snowflake. Hear that name a lot, too.
You do. Its architecture is quite clever. It separates compute power from storage.
What's the benefit of that?
Scalability, mainly. You can scale your processing power up or down instantly, independently of your stored data. It offers automatic scaling, runs across multiple clouds, AWS, Azure, GCP, and has this feature called zero-copy data sharing.
Zero-copy sharing.
Yeah, it lets different teams or even different organizations securely share live data without actually copying or moving it. Very efficient for collaboration.
Sounds very flexible. Best use cases.
Perfect for enterprise data warehousing in the cloud. That cross-organization data sharing, migrating legacy warehouses, and building real-time data applications.
Okay, got it. Now, amidst all these, advanced specialized tools, what about the old standby?
Ah, you mean Microsoft Excel.
Exactly.
Yeah.
Is it still relevant in the world of big data and AI?
Surprisingly, yes. Hugely relevant, actually. Don't underestimate Excel.
Why is that?
Its accessibility and familiarity are unmatched. Almost everyone knows the basics. Plus, it has powerful features built in. Pivot tables for summarizing data quickly, lots of statistical functions, Power Query for data cleaning and transformation.
Power Query is pretty powerful, I've heard.
It really is. And you can even automate tasks with VBA. So for small business finances, quick ad hoc analysis, basic data cleaning, simple reports, Excel is still an absolute workhorse.
Amazing how it endures. The silent workhorse, you called it.
It really is. Never count Excel out.
Okay, so we've covered some massive platforms, cloud specialists, even Excel. What about tools focused specifically on AI-driven insights or self-service BI beyond the big names?
Good point. SizeSense is worth mentioning here. It's an AI-powered analytics platform.
AI-powered how?
It focuses on generating automated insights using AI, has special in-chip technology to handle large data sets quickly, drag-and-drop dashboards, and natural language query features similar to Power BI.
So automation and speed are key there.
Yeah, definitely geared towards automated BI, customer analytics, financial forecasting, things like that.
And you mentioned QuickView earlier in self-service.
Right. ClickView and its successor, ClickSense, they're known for their associative data model.
Associative model, what's that?
It means when you click on something, the tool instantly highlights all related data across all your charts and tables, even data not directly selected. It lets you uncover hidden connections very intuitively.
Ah, interesting. Like exploring connections freely.
Exactly. Combined with in-memory processing for speed, it's great for self-service analytics, especially in areas like sales, supply chain, healthcare, retail analysis.
Okay. Any open source contenders in this space?
Absolutely. Kename, pronounced Neem, is a big one. It's an open source analytics platform.
Open source, so free to use.
The core platform is, yes, its strength is its visual workflow designer. You drag and drop nodes representing different data operations to build your analysis pipeline. Very intuitive, even for complex tasks.
Sounds like a no-code, low-code approach.
Very much so. It has over 2,000 modules for everything from data prep to machine learning, and it integrates well with R, Python, Spark if you need to add custom code.
So flexible and visual. Use cases.
Great for data pre-processing, building predictive models. It's used a lot in pharmaceutical research, credit risk scoring, and marketing analytics, too.
One more, maybe something different. What about analyzing machine data, logs, that kind of thing?
For that, Splunk is the dominant player. It's specifically designed for analyzing machine-generated data.
Like server logs, network data.
Exactly. Logs, events, metrics from IT infrastructure, security devices, applications. Its key features are real-time indexing and searching of massive amounts of this data, advanced security information and event management SIEM capabilities, and a machine learning toolkit for detecting anomalies.
So crucial for IT ops and cybersecurity.
Hugely. Best use cases are IT operations monitoring, cybersecurity threat detection, application performance monitoring, and compliance reporting. It turns machine data into operational intelligence.
Wow, that's a fantastic overview of the major tools. It really highlights the diversity out there.
It's a rich landscape for sure.
So stepping back from the individual tools for a moment, what does all this capability really mean? Let's revisit what data analytics actually is in this context and why it's so transformative.
Yeah, it's good to anchor back to the core concept. Data analytics fundamentally is that systematic process, right? Examining raw data to find meaningful insights, spot trends, uncover patterns.
And the goal?
The goal is always to use those findings to inform decision-making, to drive better business strategies. It involves applying all sorts of techniques, statistical algorithms, machine learning, and, of course, leveraging these powerful tools we've been discussing.
On both structured and unstructured data you mentioned.
Crucially, yes. Handling both is key today. And this whole process, we generally break it down into 4 main types of analytics. Each builds on the previous one.
Okay, let's quickly recap those.
Sure. First is descriptive analytics. This is the what happened stage. Basic reporting, calculating averages, looking at historical data, your standard dashboard.
Foundational stuff.
Exactly. Then comes diagnostic analytics. This asks, why did it happen? It involves digging deeper, maybe data mining, looking for correlations, root cause analysis.
That's understanding the past.
Right. Then we move into the future with predictive analytics. This is about what will happen, using statistical models, machine learning algorithms to forecast future trends, customer behavior, things like that.
Getting proactive.
Yes. And the final stage, often the most valuable, is prescriptive analytics. This goes beyond predicting and asks, what should we do about it?
Actionable recommendations.
Exactly. It uses optimization algorithms, simulation modeling to suggest the best course of action to achieve a desired outcome, like optimizing pricing or inventory levels based on predictions.
So it's a journey from understanding the past to shaping the future.
That's a perfect way to summarize it.
And this isn't just theoretical tech talk. You see this making a real, tangible difference in how businesses operate, right?
Oh, absolutely. The impact is profound when done right.
What are some of the biggest impacts you see consistently?
Well, the most immediate is usually enhanced decision-making, moving away from gut feelings or guesswork towards choices backed by solid data and insights.
Makes sense. Less risk, better outcomes.
Definitely. This naturally leads to improved customer understanding. Analytics helps uncover customer behavior, preferences, pain points, allowing for personalization, better targeting, stronger relationships.
Know your customer deeply.
Critical. We also consistently see increased operational efficiency. Data can shine a light on bottlenecks, inefficiencies in workflows, areas for streamlining,
Saving time and resources.
which connects to the next point: reduced costs and risks. Analytics can predict things like fraudulent transactions, potential equipment failures, compliance issues, allowing businesses to act preemptively.
Avoiding costly problems.
Exactly. And maybe the most exciting part is how it fuels innovation and competitive advantage. Insights into market trends, unmet customer needs that's gold dust for developing new products, services, and staying ahead of the curve.
Finding that edge.
For sure. And ultimately, successful implementation fosters a true data-driven culture, where decisions at every level, from the intern to the CEO, are informed by data. That's transformative.
That really paints a compelling picture. But it brings us back to a crucial point.
Mhm.
Okay, the benefits are clear, the tools are powerful. But how do you, the listener, actually choose the right tool for your specific needs? It feels like a high-stakes decision.
It can feel that way, yeah, because it often involves significant investment in time and money. But you can break down the selection process systematically.
Okay, what are the key steps?
First and foremost, define your goals. What do you actually need the tool to do? Is it basic reporting? Complex predictive modeling? Interactive dashboards for the sales team? Your end goal has to be crystal clear.
Start with the why.
Always. Second, you need to honestly assess your team's skills. Do you have data scientists who can handle complex coding, or do you need something more user-friendly, maybe low-code or no-code for business analysts? The tool has to match the users.
Right. Adoption is key. A
Mhm.
fancy tool no one uses is worthless.
Precisely.
Right.
Third, map your data sources. Where does your data actually live right now? Spreadsheets, cloud apps like Salesforce, databases, data lakes. You must ensure the tool can connect easily and reliably to your existing data infrastructure.
Compatibility check. Very important.
Non-negotiable. Fourth, I always recommend, pilot a few options. Don't just rely on demos or sales pitches. Shortlist 2 or 3 tools and test them with your own data on real tasks your team needs to perform.
Try it before you buy, essentially.
Exactly. Get hands-on experience. It reveals a lot.
Makes sense. Good us.
Finally, rigorously evaluate performance, governance, and cost. How fast is the tool? What are its security features? How does it handle user permissions and data privacy? And crucially, understand the pricing model. Is it per user, per usage, a flat fee? Consider the total cost of ownership.
Speed, security, scalability, cost. Got it. That's a solid framework.
It helps navigate the complexity.
Now, looking ahead, this field isn't standing still, is it? What's fascinating is how rapidly it's all evolving. What trends should we be watching for, say, 2025 and beyond?
Oh, it's moving incredibly fast. Several key trends are really shaping the future. One is adaptive AI.
Adaptive AI, different from regular AI.
Yeah, think of AI systems that don't just learn initially, but continuously learn and adapt based on new data and changing circumstances after deployment, like a self-driving car constantly refining its responses to new road conditions.
So AI that keeps getting smarter on its own.
Essentially, yes, more resilient and flexible. Another huge one is natural language processing, NLP.
And we touched on that with some tools.
Right, but its importance is only growing, with estimates suggesting like 80–90% of data is unstructured text, voice, social media. NLP is becoming essential for unlocking insights from that massive chunk of information, making computers truly understand human language.
Tapping into that huge pool of unstructured data.
Exactly. Then there's edge computing.
Bringing the computing closer to the data source.
Precisely. Instead of sending all data from, say, sensors on a factory floor to a central cloud for processing, you perform some analysis right there at the edge. Reduces latency, saves bandwidth. Crucial for real-time responses.
Makes sense for things like IoT.
Definitely. We're also seeing the continued rise of cloud-native architecture, building applications specifically for the cloud using microservices, containers. It offers amazing scalability, resilience, and deployment speed.
Built for the cloud, not just moved to it.
That's the key distinction. And empowering more users is the trend of self-service data analytics. We talked about self-service tools, but the trend is towards making these even more accessible, often with low-code, no-code interfaces, so domain experts can do their own analysis without being data scientists.
More democratization of data.
Right. And finally, looking a bit further out, there's quantum computing.
Quantum still feels a bit sci-fi.
It's definitely early stages for practical application and analytics, but the potential is immense. Quantum computers using qubits could theoretically process certain types of complex calculations, like optimization problems, exponentially faster than today's computers.
Potentially game-changing for certain industries.
Could be, for things like drug discovery, material science, complex logistics, but still some way off for mainstream analytics.
Fascinating stuff on the horizon. And it's clear these tools, these trends, they aren't just abstract concepts, they're actively reshaping industries. Can you give us a few concrete examples of how analytics is transforming different sectors?
Oh, absolutely. The impact is everywhere. Take retail. Analytics drives hyper-personalization in online shopping, optimizes inventory through better demand forecasting, and is crucial for detecting fraudulent transactions.
Big impact on the bottom line there.
Huge. In finance, it's fundamental for sophisticated risk management models. It powers high-frequency trading algorithms and enables banks to offer highly personalized financial products and advice.
Critical for that industry.
Definitely. Look at healthcare. Analytics is enabling precision medicine by analyzing genomic data. It helps hospitals predict patient readmission risks to improve care and significantly accelerates the incredibly complex process of drug discovery.
Potentially life-saving applications.
Truly. In manufacturing, predictive maintenance, using sensor data to predict machine failures before they happen is a huge cost saver. Plus, optimizing complex global supply chains and ensuring quality control.
Keeping the factories running smoothly.
And efficiently. And finally, think about marketing. Analytics enables highly targeted advertising campaigns, helps map and understand the entire customer journey across different touchpoints, and uses social media listening to gauge sentiment and refine messaging.
Making marketing smarter and more effective.
Exactly. The applications are practically endless.
It's clear that navigating this world, the tools, the trends, the applications can be complex. This is often where expert partners become invaluable, wouldn't you say?
Absolutely. Making the right choices, implementing effectively, and extracting real value often requires deep expertise. And, well, that's precisely where we at Canerica come in.
Tell us a bit about that.
Sure. At Canerica, we help businesses make better, faster use of their data. As a trusted Microsoft data and AI solutions partner, we have deep expertise in leveraging industry-leading tools, particularly Microsoft Fabric and Power BI.
So focusing on that Microsoft ecosystem.
We have strong capabilities there, yes. But our focus is always on building practical solutions that solve real-world business problems for our clients. Whether that's cleaning up messy internal processes, finding ways to significantly reduce operational costs, or boosting team productivity through better insights.
Delivering tangible results.
That's the goal. Our advanced analytic solutions are designed to make a measurable difference, helping companies across finance, healthcare, manufacturing, and other industries make smarter, data-driven decisions much faster.
Helping bridge that gap between the potential of these tools and actual business value.
That's exactly what we aim to do.
Oh, this has been an incredible deep dive. We've journeyed through the landscape of data analytics tools, from the workhorses to the all-in-one platforms, seen how analytics works, and explored the trends shaping its future.
It's a dynamic and powerful field.
It really is. We've seen how these tools transform raw data into critical insights, impacting everything from your streaming choices to the efficiency of global supply chains.
And if we connect this to the bigger picture, as the sheer volume, velocity, and variety of data just keep exploding, being able to harness these advanced tools effectively, it's shifting from being just a competitive advantage to becoming a fundamental prerequisite.
A necessity for survival and innovation.
I really believe so. It's becoming essential for sustained success. And that perhaps leaves us with a final thought, a question for you, the listener.
Go on.
How will you leverage these kinds of insights and tools, this potential, to redefine what's possible in your own data journey, whether it's for your business, your research, or even just understanding the world around you better?
A great challenge to end on. How will you use this power? Thank you so much for guiding us through this complex world today.
My pleasure. It was a great discussion.
And thank you for joining us on the Deep Dive. We hope this exploration sparks further curiosity and helps you navigate your own data challenges. Until next time.